Hey guys, this lesson is going to look at solving literal equations. And a literal equation is an equation that's made up of mostly variables. There may be a few numbers in there, but it's mostly letters, always more than one letter. And so when you look at solving a literal equation, they're not asking you to actually solve and get a value for the variable they're talking about, because there's not going to be a way to get a number value for that particular letter. When they ask you to solve a literal equation, they're asking you to rearrange that equation so that you're setting the formula up so that it's equal to that particular letter instead of another one. So when they ask you about literal equations, we're talking about being able to rearrange them to solve for a given variable. So this can be kind of tricky for some people. Other people seem to get it pretty easily. But it really just follows the same steps that we do when we solve a regular equation. We're just not going to really be able to combine things with this like we normally can. So let's talk a little bit about what a literal equation is. A literal equation is an equation that consists of mostly variables. So again, it's made up of mostly letters. Formulas, like those formulas you use in science or the formulas you've used in the past for like measurement and stuff, are the most common literal equations. So you may be familiar with some of these. Slope-intercept form, y equals mx plus b. That's a literal equation. Pythagorean theorem, a squared plus b squared equals c squared, would be a literal equation. Volume formula, like volume equals length times width times height, or area equals 1/2 base times height. Those are all literal equations. Other things like force equals mass times acceleration, ma, literal equation. So you use a lot of these things in science classes and in math classes too, or to find measurements of things specifically. So these literal equations are again, made up of mostly letters, but they still use same mathematical operations. Like this y equals mx plus b. In that, we see multiplication between the m and the x, addition with the b. Or here with Pythagorean theorem, we've got addition, we've got exponent values. We've got multiplication over here in this volume formula. So all of the operations are still there. So we can still use the same rules to solve them. We're just not going to be able to actually combine numbers anymore. So how do we solve a literal equation? The first thing you want to do is identify the letter that you're solving for. I usually do that by highlighting it or boxing it in or something so that that letter by itself has my attention. Because there can be so many other letters in there that sometimes it's easy to get lost in the middle of it. So identify the letter they're asking you to solve for. If it helps you, you can flip the equation around so that that letter is on the left side. Now, you don't have to do that, but you can. Mathematically, it will work either way. But some people prefer to have the thing they're looking for on the left, so you have that option to do that. Then you're going to use inverse operations to isolate the variable. So remember, inverses are opposites. So the opposite of addition is subtraction. Opposite of multiplication is division. And as you're using those inverses, you're going to use PEMDAS, but you're going to have to do it backwards. So that means that you're going to undo the addition or subtraction before you undo multiplication and division, and you actually deal with your parentheses last in this situation instead of first. So you've got to kind of get used to working in reverse as you do these inverses, and that's going to make this a little bit easier for you. So let's remind ourselves of our inverses. Inverse operations are addition is the inverse of subtraction, multiplication is the inverse of division. And then we didn't talk about this in the last lesson on solving equations, but what about an exponent? What if you need to do the inverse of an exponent? Anybody remember what that is? I'm trying to write the word exponent. If you remember the inverse of an exponent, so the inverse of like squaring something or cubing something. If you have a number squared, like 4 squared equals 16. How do you get from 16 back to the idea that 4 squared is 16? Maybe you remember that a square root would be able to tell you what squared becomes that number. So a root is the opposite of doing an exponent. So if you have to undo an exponent, you use a root. A square root is the opposite of a squared exponent. A cubed root is the opposite of a cubed exponent. And that doesn't come up a whole lot, but it does come up sometimes, and so we want to make sure we know how to undo that if we need to. Now, you always undo the things in parentheses last. We already talked about that. And something else that you kind of have to get used to with these literal equations is that you don't usually do distributive property. Normally, we're used to, if we see parentheses, we clear those first by doing distributive property. But with inverse operations, you don't do that, because if you distribute something, you're just going to have to turn around and have to remove it from everything you distributed it to. So instead of doing distributive property, we just go ahead and divide that number off at the beginning. So instead of doing distributive property, divide by whatever's outside of the parentheses, because it's being multiplied anyway. So its inverse would be division. So we divide that number off, and then that clears that off of that side as we're trying to move things around. All right, let's look at some examples of this. Okay, so here is a really simple example of this. This first one says solve E equals IR for R. So again, what I recommend that you do is start out by identifying the thing that you're solving for. They ask you to solve for R. So this R right here is what we're going to try to get along. So you have options here. You can leave this in this order and just move the things that are on the right side to the left side to get rid of what's on the same side as the R, so R is by itself. Or if you prefer to flip it around because you're used to having the thing you're looking for on the left, you can move it and make it say IR equals E. It honestly does not matter. It's the same thing either way. But if you prefer to have the thing you're looking for on the left, do that. And that might make it feel a little more natural to you. So I've got this. I'm looking for R. And so I'm going to use the same rules that I used for solving an equation to solve for R here. So I'm going to split the world. On the same side as my R is this I. And because they're side by side like that, I know I is being multiplied with R, because two things next to each other are multiplication. So to undo multiplication, I'm going to do the inverse. Inverse of multiplication is division. So I can divide by I on both sides. I divided by I will cancel, and I can bring down R. If I divide by I here, I'm going to divide by I here. E divided by I is exactly that, E over I. You can't combine that together because they're just letters. And so that's the answer. R is equal to E over I. We've rearranged that formula so that it's R equals instead of E equals. That's what they've asked us to do. All right, look at the next one. Solve D over T equals R for T. So we're looking for T. This is a little bit different. Now, if we look on the same side as T, we've got D divided by T. So we can undo division by multiplying. But the trick to that is that the T is the thing being divided. So to undo the division of T, we can only multiply by T. We cannot multiply by D because D is not being divided. So T gets multiplied by T to cancel out division of T, which means I have to come over here and multiply by T on this side too. That leaves me with a D on this side and R times T on this side. But that's not what they wanted. They wanted me to solve for T. So I kind of moved the wrong thing, but there was no other way to go about doing that. That was the only thing I could move. So now I've got to find a way to get rid of the R that's on the same side with the T. So since R is being multiplied by T here, I can divide it. And that brings my T down below. And over here, D divided by R is exactly that, D over R. So T is equal to D over R. All right, let's take a look at some more. All right, this next slide's got two different problems on it. I'm actually going to work the bottom one before I work the top one, because the bottom one's a little bit simpler than the top one. The top one's really tricky for some folks, and so that'll give us one more to look at, and you kind of get your minds around before we look at the more complicated one up above it. So Looking at this bottom one where it says solve R equals CS over D for C. So I've got here two other things on the same side as C that I'm going to have to move in order to solve for, or to rearrange this thing for C equals. So what I'm going to do with this is I'm going to start out by flipping it around so that the C is on the left side. And R is on the right. And that way, everything ends up on the right side that I like it to be on. So when I look at what's going on the same side as my C, I've got division with the D, and I have multiplication with the S. So since the D is being divided for both the C and the S, because it's underneath both of them, I'm going to undo that division before I undo the multiplication between the C and the S. So to undo that division of D, I can multiply by D, because multiplication is the inverse of division. I wasn't trying to write with a highlighter, sorry. So D cancels D. If I multiply by D here, I multiply by D over here. So that leaves me with just CS. Oops. And then over here, I'm going to have R times D. So the last thing I need to do is find a way to split the C and the S up, because I've got to get the C by itself. So to remove the S that's being multiplied by it, I'm going to just divide by S. So that means my C is now alone. That's all I have left is C. And RD divided by S is it. So this one is going to be C equals RD over S. Again, none of this can go together because it's just letters. It's not numbers that can actually be divided or multiplied. So we just leave it set up in that format. Now this next one is a little bit tricky. So in the top up there, they ask us to solve for B1. So I've got all kinds of other things going on here. I've got multiplication with the 1/2 and the H and the stuff in parentheses here. And then I've got addition within my parentheses. So if you remember, we talked about if there's parentheses, we have to do PEMDAS in reverse. And so we're going to undo anything outside of the parentheses before we try to undo things that are inside. And we're not going to do distributive property with this stuff, because with distributive property, we're just setting ourselves up to have to go back and undo it afterward. So instead of doing that, I'm going to start out by dividing off the thing that's trying to be multiplied into this to get rid of it. So that means I've got to divide the 1/2 and the H. And I can do both of those at one time. So I'm going to go under here, divide 1/2 and H on this side, divide 1/2 and H on this side. Now, here's a part of this that gets a little bit tricky. If you remember many, many moons ago when you were in 5th grade, you would have learned how to divide fractions. And when you learned to divide fractions, you learned about KFC, which was keep, flip, change, or you might have done KCF, keep, change, flip, whatever. And that meant that you took a set of fractions that you were dividing, like 1/2 divided by 2/3. By the way, you don't have to write this down. And you would keep the first one, flip the second one over, that's called a reciprocal, and change it to multiplication. You have to do the same thing when you're dividing with a fraction here. If you are rearranging one of these and you end up with a fraction on the bottom of a fraction, you have to do KFC. You have to actually multiply by the reciprocal instead. So if you have to divide by a fraction, you should multiply by its reciprocal. That means dividing by 2/3 would be the same thing as multiplying by 3/2. So for this, if I'm dividing by 1/2, instead of dividing by 1/2, I need to treat this like I'm multiplying by 2/1. So that means the 2 goes up to the top, and the 1 stays on the bottom with the H, but I don't really need a 1 on the bottom, so I'm just going to put H. So 2 times A over H equals, and then on this side, all I have left is B1 plus B2. So since there's nothing else to separate it from, I don't even need my parentheses anymore. I can just bring them down, B1 plus B2. Change the color of all that. Okay, and again, for my folks that, just in case this is lost you here, I got 2a over h because the 1/2 that was on the bottom had to flip over and become 2 over 1 and multiply. So the 2 multiplied with the a, the 1 multiplied with the h, but 1 times h is just h, so I didn't write the 1 down there. Okay, so from here, all I have left is to get rid of that b2, because I want b1 by itself. And so since b2 is being added, I can subtract it. Now this gets a little bit weird. So that leaves me with b1 is equal to, you can't subtract b2 from any of this stuff. So I end up with 2a over h minus b2. And that is the solution. That is probably the most complicated that these problems get for the most part. Something like that. Which is plenty complicated, really. All right, let's look at a few more. All right, here we have some word problems. They put them in word problems too, but it's really not any different to work with. This one says, volume of a prism can be calculated using the formula V equals LWH, where V is volume, L is length, W is width, and H is height. Solve the formula for H. So we're trying to rearrange this formula for H. So I'm going to start out by writing that down, but I'm actually going to write it backwards so that my H stays on the left side because I prefer that. So LWH equals V. And I'm going to change this. My L's and my 1's look the same, and I don't want to be confused. So L, there we go. So if I want to solve this for H, I've got to find a way to get rid of the L and the W that are on the same side. And so since L, W, and H are all being multiplied, and I know that because they're all side by side by side, I can undo that multiplication using its inverse, which is division. If I divide by LW here, I can also divide by LW here. Now, these are not fractions, so I don't have to do that weird fraction rule that I did on the last one for this. So my H comes down, V over LW. And that's it. A really simple question with that one. All right, here we have one for perimeter. Perimeter of a triangle with side lengths of A, B, and C is P equals A plus B plus C. Solve this formula for B. So, again, I'm going to write that the other way around. A plus B plus C equals P. So if I'm going to solve this for B, I've got to get rid of the A and the C that are both on the same side. And since they're all being added, I can subtract A, and subtract C to get rid of. So that means my B is equal to P minus A minus C. And that'll be it. All right, so this next one is a little bit different because it includes an exponent. And so we're going to get to see what happens when we have that scenario here. But they ask us to take the formula for area of a circle and solve it for R. That means I got to get this little R by itself. So I'm going to write that down as pi R squared equals A. And then I'm trying to get R. So that means I've got to find a way to undo or to remove the pi and the square that are on the same side as the r, because I need to get this away and this away, so the r will be alone. So with this, we've got two different operations. We got multiplication between pi and r, because they're side by side. And then we have this exponent. So remember, we've got to work PEMDAS backwards, which means we need to undo the multiplication before we try to undo the exponent. So to undo multiplication by pi, I can divide by pi. Pi divided by pi will cancel. I'll divide by pi over here. So that brings r squared equals a divided by pi. Now I have to think about what do I do to undo an exponent. And so if you remember when we looked at the rules for inverses, addition was inverse with subtraction, multiplication was inverse with division, exponents are inverse with roots. So we can undo an exponent of 2 by finding the square root on both sides. So the square root of r squared is just r. The square root of a over pi is exactly that, root of a over pi. And that would be my rearranged formula. All right. Here's another one, kind of complicated. The formula E equals 1/2 kx squared is used to find the potential energy E of a spring with spring constant K that has been stretched by length x. Solve the formula for K. Now, I'll be real honest with you. This formula is super sciencey and all that stuff about potential energy and spring constant K stretched by length x. That means nothing to me. I'm not a sciencey person, so all that just feels like gobbledygook. But I do know enough about math to know how to rearrange this so that it is solved for K. So I'm going to look at this. I don't want to get caught up in all the jargon that's in that problem. I'm looking at this and I'm saying, okay, I'm solving for K. Here's K. So I'm going to take that, rearrange it. I'm going to put 1/2 kx squared equals E. That way K is on the correct side. And I'm going to look at what else going on over there with the K. So if you look at the K, I've got a half being multiplied by it on this side. And I have x squared being multiplied by it on this side. So all of this is multiplication. 1/2 multiplied with the K, x squared is being multiplied with the K. The square that's here is on the x. So I don't have to split these up. On the last problem, we had to get the square off of the r because we needed r by itself. But the square is on the x, not on the k. So I'm not going to have to use a root to undo the exponent in this problem. If the exponent was on the k, I would need to get it away from the k. But it's on the x, so it'll just divide off with the x squared when I go to do that. So since 1/2 and x squared are both being multiplied, we'll divide them both at one time. So 1/2 and x squared are both being divided at once. That lets me just bring down my k. If I divide by 1/2 and x squared on this side, I'm going to divide by 1/2 and x squared on this side. Now, this is one of those exceptions where when we're dividing by a fraction, we've got to remember to turn that around and flip it over and multiply. So instead of dividing by a half, I'm going to multiply by 2/1. All right, I'm not sure exactly where I was. Kicked Jake out of my classroom. Anyway, back to what we're doing. So instead of dividing by half, we're going to multiply by 2/1, which means the 2 goes up to the top with the e, and the 1 would stay on the bottom with the x squared. But because it's a 1, it doesn't actually have to be there. So I end up with 2e over x squared. And that's it. So again, if you're wondering, like if this is tripping you out, because I feel like it probably is getting some people, this division of a fraction thing, anytime that comes up, whatever's on the bottom of the fraction moves up to the top. whatever's on the top stays on the bottom. It just flips over. So 2e over 1x squared. But you don't need a 1 because a 1 doesn't mean anything. So we just write it as 2e over x squared. So don't let that part trip you out. That's probably the toughest part of any of this, or the easiest part to get confused about. All right, next one. The formula for, actually, let's take a second, or I'm going to stop right here. Not stop. I'm going to stop teaching and let you take a moment to try these. So try the one on this slide and the one on the next slide, and then come back and see if you got your answer correct. So pause the video, see if you can work those by solving for the letter they ask you for, and then come back and see if you were right. And hopefully you'll find that you are finding some success with this kind of stuff. So pause the video right here, work them out, come back and see if you're correct. Okay, so we're back. If you look at the way I worked this out, hopefully you were able to get that h would be equal to v divided by pi r squared. And the way I did that was I noticed that pi and r squared were being multiplied with h because they're all side by side by side. So to get rid of the pi and the r squared, I just divided them both off of there. Divided by pi and divided by r squared will cancel. So I came on this side and did the same thing, divided by pi, divided by r squared. None of this was fractional, so it could just stay just the order it was in. V divided by pi r squared gave me h. That was a pretty simple problem. It looked like it would be complicated, but it ended up not being so bad. And then this next one was a little bit tougher because it had a fraction in it and an exponent, and so you had to undo all of that to get the r by itself. So if you look at the way that was set up to start with, it's 1/3 times pi times r squared times h to get v. And so if you're trying to get r alone, the first thing you've got to undo is that multiplication. So you can undo the 1/3, the pi, and the h by dividing it all. Divide by a third, divide by pi, divide by h. Cancels, cancels, cancels. And so I did the same thing here. And that allowed me to get r squared by itself. So I brought my r squared down. This, we had to do a little bit of that flip thing because it had a fraction in it. So the 1/3, the 3 flipped to the top, the 1 stayed down. So I ended up with 3v over pi h, or 1 pi h if you left your 1 in there. And then I had to find a way to get rid of the square. So the square root cancels the square. So I did the square root of this side to get plain old r, and I did the square root of this side so it would stay balanced. None of this could be square rooted, so it just stayed as the root of 3v over pi h, which was answer choice D. Okay, that's the end of that lesson. Y'all have a beautiful day.